Okay, so this is part 284C3m1b7c8e3e, and it's line 22f1fa19c3m1b7c8e3e Bohr, hydrogen, electron, atomic formula, UFO, 5G Wow Seti. Here's the alien radio signal, and this is the keyword research UFO engine formula. The IDs are based on the data from previous videos. And so there's about 10 videos in this particular section here, if you're working on the engine part, or the power for the engine. We have laser beams, we have x-rays, microwaves, and crystals in the formulas, okay? So December 7th, 2012, today is December 25th. The keyword research from formulas in previous video is line 22 F1FA19C3M1B7C8E3D, Spectroscopy QELS DLS, Neutrino laser beam 5G Wow Seti. So I'm going to Google the Bohr model, and that's what it looks like. Quotes from WIKI. The Rutherford Bohr model of the hydrogen atom, Z equals 1, or a hydrogen-like ion, Z is greater than 1, where the negatively charged electron, confined to an atomic shell, encircles a small positively charged atomic nucleus, and where electron jump between orbits is accompanied by an emitted or absorbed amount of electromagnetic energy, HV. The orbits in which the electron may travel are shown as gray circles. The radius increases as n2, where n is the principal quantum number. The 3 to 2 transition depicted here produces the first line of the Balmer series, and for hydrogen Z equals 1, it results in a photon of wavelength 656 nm red light. December 6, 2012, my thoughts. The keyword hydrogen keeps coming up in many of the previous videos from lines 17 to 22 WOW data. We also cover hydrogen storage, hydrogen formulas on how to use it as a power source for this UFO spaceship idea. Formula from the data: hydrogen, negatively charged electron, confinement, atomic shell, encircles, small area, enclosure, small positively charged atomic nucleus, electron jump between orbits. UFO can jump orbit rings in space to travel faster across rather than around an object or a planet, star, whatever. Emitted, absorbed electromagnetic. I need to spell, right? Missed that one. Electromagnetic energy sends out an electromagnetic signal into the dark matter, which absorbs it and creates the electromagnetic energy generated by the core. We're talking about the core of the spaceship. Electrical short pulses of X-rays to travel through space. So this is how this is going to work. So it's orbit, electron, travel, gray circles, UFOs. Radius increases as n2, n equals principal quantum number 3 to 2 transition depicted produces first line. Balmer series, hydrogen, Z1, Z equals 1. So we remember the symbol for Z is 0. So 0 equals 1. So results, photon after Higgs field signal has produced the 2 photons. You're going to add a wavelength plus 656 nm. You want to use red light spectra. Smaller particles can be seen and used to generate faster than the speed of light in dark matter deep space travel. Okay? So you have your nucleus, your proton, neutron, electron. So quote from blog. Niels Bohr's model of the atom has electrons that move around the nucleus in paths. The protons are in the nucleus, which is in the middle of the atom. So we have our star shape here. 1, 2, 3, 4, right? And then we have our nucleus in the middle, kind of like the atom in the middle, right? Or the core. Yeah, you see where I'm going? Okay, the website is 2011.7group3.wikispaces.com. Okay, so December 6th, the middle is the core of the UFO, right here. The circles around it are particles, metal alloys that rotate the UFO spaceship forward through dark matter and deep space, making it spin forward. What do you think of that? Cool, right? Okay, so electron transitions. The Bohr model for an electron transition in hydrogen between quantized energy levels with different quantum numbers, n yields a photon by emission with quantum energy. So I got this here. A downward transition involves emission of photon of energy. Given the expression for the energies of hydrogen electron states, this is often expressed in terms of the inverse wavelength or wave number as follows. Here's the other. It's called the Rydberg constant. Okay. I found that on hyperphysics.phy-astr.gsu.edu. Okay. And then this one here, it's hard to read because of the little puny letters. Now you've got glasses on. Okay, this is from the Bohr model, and it says Lyman series ultraviolet, Passion series infrared. It says blue-green, so there's our blue shift, red shift stuff, right? And now we got violet there, red. Balmer series visible. We were talking about the visible dynamic light scattering as part of the. It is going to be part of the power. Okay, and that's what it looks like there. So this spectrum was produced by exciting a glass tube. So we're talking about nanotubes before in the design. So this is talking about a glass tube which would be made of obsidian and nanoparticles. So the glass tube of hydrogen gas with about 5,000 volts from a transformer. It was viewed through a diffraction grating with 600 lines to mm. The colors cannot be expected to be accurate because of differences in display devices. For atomic number Z equals, a transition from N2 equals to N1 equals will have wavelength of the symbol equals Nm and quantum energy H3. So we're going to be generating some sort of quantum energy here. Hyperphysics.phy-astr.gsu.edu is the website that was found on. So December 6th, the keywords. We have X-rays, gamma rays are used in the laser beam to short pulse the UFO engine forward with the design ideas given in the WOW alien radio signal data. Okay. This was the test thing for faster than light from CERN. Let me make it a little bit bigger there so we can see it. There. So it says a high energy beam of muon neutrinos, subatomic particles, is generated through a collision of protons and a graphite target in CERN's superproton synchrotron accelerator. CERN is Geneva. We got the Alps. This is the photon and the LNGS lab from Gran Sasso. Down here are the Ta neutrinos and muon neutrino, 732 kilometers. The trinos will travel 732 kilometers through the Earth's crust from CERN. I'm going to make it a little bit bigger. Then beam through the detector that measures the precise time they leave CERN via GPS technology. During their journey, the beam of muon neutrinos turn into Ta neutrinos and back again, a process known as oscillation. That's cool. So, 2.4 milliseconds after leaving CERN, the neutrinos arrive at Gran Sasso. Boy, it didn't take them very long, did it? Their arrival is detected when they collide with bricks of photographic film interleaved with sheets of lead. Ah, okay. Remember we were talking about that series of how to take the photos and the different types of flashes and how to set them up? Those come up in line 22. So, I wonder if you need to put them in with this, check the formulas for that, because I know we're talking about how to collide neutrinos to find more particles and to generate more energy. That's also coming up in the WOW data as well. So according to the experiment, the neutrinos traveled faster than the speed of light. Okay. Of course, there was some controversy about that, and some things didn't go right, and other things went right, but other than that, they're working on making that happen. Okay, so according to the experiment, the neutrinos travel faster than the speed of light. So the speed of light is 299,792,458 meters per second. That's fast. Estimated speed of neutrino was 299,798,454 meters per second. Okay, so the Gran Sasso detector has 150,000 bricks with a total mass of 1,300 tons. Wow, that's a lot. Sheet of lead photographic film. Isn't that cool? And they have little photographic films going through each piece of lead. So I can't read the words on this one. Sorry. It talks about the neutrino beam and it's got all these little words here. Something. Oh, that's CERN. And then I think it's a list of different places that it goes through to get there. There's a Grand Sasso laboratory. So these must be all different little labs or something. I don't know what they are. I can't read it. Sorry. So it's cr4globalspec.com. I don't know if we can make it bigger or not. It's annoying when we can't read it, can't you? Oh, there we go. Can we make it bigger? No, I still can't understand it. Sorry. It's too blurry. Okay, December 6, 2012. The keyword from the data is going to be tachons, and I'm going to research that in the next video. Okay? Thanks for watching.